So these are the answers to the conversion problems. If there are any that you have questions about, I'd be happy to answer those. Yes.
Number 8, isn't it 3 to the left? Is it 3 to the left?
Yeah. Oh yes, so it's so your liters. So we're going milli to basic. So 3 to the left. So 1, 2, 3. So the correct answer 0.075. Yes.
Is it okay if we leave that first 0 off?
Right. If you're in the habit of doing that, just try to get in the habit of putting it there. I know it's kind of, you're used to it, but when we get to more conversion problems, it will be helpful to have that. Other questions?
No question? You want us to put a 0 at the end? Like 4, 11.
No, 11. So if you put a 0 at the end in number 11 or left it as is, right now, I would accept either. But 0.5 is technically correct in terms of sig figs.
So for 15, it would be 0.12.
0.12.
I just want the same things as the number,
Right.
the original number. So like 120, there's only two sig-figs, and then 0.12 is 2 sig-figs.
And if the sig figs are going over your head right now, that's fine because we haven't really talked about them. So don't get too wrapped up in this. Other questions? Calculators for this course. I haven't talked about calculators. Graphing calculators are not allowed for the quiz or exams. Same thing goes if you ever have to take an exam in the testing center. Non-graphing calculators are all that they let you take the exams with. So if you're going to get, if you have just only graphing calculators and you need to get a non-graphing calculator, this calculator is one I highly recommend. I don't know if you can see. It's a Texas Instruments TI-30X2S. The thing that's great about this calculator is it has a 2-line display. So when you're working these problems, and we'll get into more conversions where there are many steps. You don't necessarily need a calculator for the conversions we have just done. But there will come a time when you need a calculator. What I like about this calculator is that it shows you what you've entered to get that answer. Now, there are other brands too, like this Casio. I guess it's FX300MS. This also has 2-line display. So that makes it really handy. When you compare it to just a basic single-line calculator, you're not really sure what you've entered. And once you see how much some of the work is required to get the conversion problem set up, you want to make sure that you don't make a mistake on the calculator entry end of it. It does happen. I have students who make calculator mistakes, and I don't count off a huge amount. If you have your work set up, and I can tell where you are going, if it was a 5-point question and it was just a calculator error, I might take off a point to get 4 out of 5 points. But, you know, I always tell the story. My husband, when he was going back to school to go to medical school, he was taking this Chem 1 and Chem 2, all these classes. And Chem 2 is a very intensive calculator course. You have to have all these calculations over and over again. And so when he was going through all these problems, he would enter it into his calculator not one time, but 3 times to make sure that he got the same answer. Because there are times when you're working these problems and you get so involved in it, and you, instead of plus, you hit times, or instead of times, you hit plus. Or maybe you just hit the wrong number. But if you hit the wrong number on these 2-line display calculators, you can see. You can double check yourself. So I heard a lot of you asking about calculators, so here's your answer. I wanted to do one more problem that comes from your pink book, and I'll project it so you can see it. So this is number 23 on page 13 of your pink book. When you're working these conversion problems over and over again, rewriting that ladder is really helpful. And I heard, can you say yours?
I do my kids and then a space holder.
So my kids, and space,
And then don't carry
Don't.
money.
carry much money, because the mu is kind of like a money symbol.
No more.
No more. Okay, very good. So that's, you know, everybody has their own ways of studying, and like coming up with these little sayings make it easier for you to remember. So I love that. So then the number of places that you need to move. What is it? How does it go? 6, 3, 1, 2, 3, 6, 9. So number 23 on page 13 of the pink book. You start off with 3 million megagram, or not million, milligrams, not mega, and you want to get to kilograms. So you're going from milli to kilo. So you're skipping over this base unit. So what you're going to do is you're going to go, you can do this in 2 steps, or you can do it in one whole step. So this would be 3 to the left and 3 to the left again, for a total of how much? 6. So if you wanted to, you could go 3, and then you're in grams, and then 3 again, and then you're in kilograms. So I'm going to move 6 to the left. So my decimals here. 1, 2, 3, 4, 5, 6. So this addresses your question, right? So how many kilograms? 3. So just 3 kilograms. So the answers to all these pink book questions can be found on page 17. So if you look at number 23, 3 kilograms is the right answer. Any more questions about these conversions?
The ones at the very bottom of that one,
Yes.
I would jump ahead. Where
That-
it starts squaring and cubing. Are we going over this later?
Thank you for asking that. You, at this point, can do all the conversions on page 13 of the pink book up until number 27. So you can do 1 through 26, just based on what we've done tonight. But if you try 27, 28, 29, 30, they're not going to make sense to you. Good question. So now we're going to move on to significant figures. And yours should be, this is an objective, so this should be bolded. So determine the number of significant figures and measured numbers. We talked a little about this in lab. Measured numbers are numbers that you obtain by measuring something. So you obtain these by measuring height, weight, or temperature. Exact numbers, you don't have to measure anything. You obtain those by counting objects. Counting objects. So 3.782 grams, 24 students. So when I give you these two numbers, which one is an exact number and which one's a measured number? The exact one is 24 students, so this is an exact number. The 3.782 grams is a measured number. So now we're getting to significant figures. So if you took a tennis ball and you weighed it on a bathroom scale, you get 0 kilograms on a bathroom scale. But I know it has some mass. I can feel it. Laboratory scale would give you 54.07 grams. An analytical balance would give you 54.07138 grams. So the precision of measurement is indicated by the recorded value using all digits known with certainty plus one additional estimated digit. So that last digit is accurate to plus or minus 1. The total number of digits used to express a measurement is called the number of significant figures. Oh, what did she just say? How does that apply to me? What do I need to know about this? If you compare these different scales, the one that's the most precise is the one that gives you the most significant figures. So the analytical balance has the most precision. The bathroom scale would have the least precision. So, and precision and accuracy, those might be terms that you've come across in other chemistry classes. We're not trying to get you to focus in on that. The main thing is significant figures play a huge role in science. If you wrote a journal article and you expressed your mass, so, oh, maybe it's 3 sig figs, 5 sig figs, that makes a huge difference because the scientific community would say, well, what is the error in this balance? Is it the plus or minus 1 to the hundredths place or the thousandths place or the millionths place? Makes a big difference. So for these measurements, the bathroom scale, how many sig figs does it have? No sig figs, so 0 sig figs. What about the laboratory scale? So 1, 2, 3, 4. so 4 sig figs. The analytical balance, 1, 2, 3, 4, 5, 6, 7. Because this 0 is sandwiched in between two non-zero digits, because 7 isn't a 0 and 4 isn't a 0, it is significant. So 7 sig figs. So at the bottom of page 5, I have some measurements, and I want to know how many sig figs are in each one. So the first one, 94.072, 5 sig figs. And 3. So remember these, and I say remember because we've seen this in lab. These are placeholders. So they don't count. What about 138,200? And then, yes, so these, there's no decimal point that's explicitly stated. So these are just placeholders as well. So 4 sig figs is the correct answer. And then the last one, 2. Go to the next page. There are 4 rules for determining how many sig figs there are in a number. The first rule is that zeros in the middle of the number are significant. So zeros in the middle of a number are significant. The example, 94.072. That 0 is significant. The second rule, zeros at the beginning of a number are not significant. They only act to locate the decimal point. So they're just placeholders. So zeros at the beginning of a number are not significant. They are placeholders. So these first 2 zeros don't count. They're at the beginning. They're just placeholders. So I always think that you can walk through these zeros. You won't run into a number. So I always just draw lines through them. All right, rule number 3. Zeros at the end of a number after the decimal point are significant. So zeros at the end of a number after the decimal point are significant. If I have 138.2 meters versus 138.200 meters, how many sig figs in this first one? 4. The second measurement, 6. So these zeros, because they come after a decimal point, are significant. And the last rule has to do with the implied decimal point. Zeros at the end of a number before an implied decimal point are not significant. So zeros at the end of a number before an implied decimal point are not significant. So we saw this with 23,000 miles. The decimal point isn't explicitly written. So it's an implied decimal point. And there are zeros before the implied decimal point. So this is another case of placeholders. So again, you can just walk through these. So this only has 2 sig figs. Questions about any of these rules? All right, so this measurement again, how many sig figs? 5. This one here? 3. 4. 4. 2. Now, it seems like, okay, I get these sig figs things. You know, it seems like, oh, I can follow these rules. Sig figs are okay until you start with calculations, because this calculator does not adjust for sig figs. So you have to use your calculator to adjust for sig figs. So that's, you know, why is she taking all this time? You will see when we start calculations, okay. So in sig figs, for whatever reason, they're very easy to forget. I find myself repeating rules over and over. And I've been at this for over 10 years now. So it's like, it's just, that's how it goes. So practice, practice, practice will make it a lot easier. In lab, we see sig figs over and over again. So in this next question, how many sig figs in A? 6. Good. How many sig figs in B? 2. How many sig figs in C? Good. And in D? 3. All right, so 3 versus what? What is everybody else thinking? 3 or 5? 5? Do you say 5? Okay, so we got a battle going on. This is great. So it might seem that 3 is a reasonable answer because we've learned about these placeholders. Placeholders. But if you look at C, see how in C there is no decimal point explicitly stated. In D, there is a decimal point explicitly stated. So now these zeros are significant, and that 0 after the decimal point is significant as well. So how many sig figs? 5.
So that's rule.
Number 3, yes. Very good. Any questions on this page? All right. So now we'll get to fun with sig figs. So it's one thing to learn the rules about how many sig figs there are, but now we're getting into the fun stuff. And this is when students really like to duke it out. How many sig figs? I don't know. I think it's 2. I think it's 5. Woo! So if you have a calculator, does everybody have a calculator? If you need one, I have calculators here too. I don't have one. You got one? Oh, you got it. You can use your phone. Yeah. So the next objective is to adjust calculated answers to the correct number of significant figures. So I have this calculation, 42.3 miles divided by 2.8 gallons. So you're trying to figure out how many miles to the gallon you got. When you enter this into your calculator, you will get, so 42.3 divided by 2.8, you will get this long answer. And you'll think, oh, I'm going to write all these numbers down. They all look so important. You don't want to leave any out. But there's something called significant figures. Now look at these units, miles and gallons. These are measured quantities. So they have a certain degree of error. You can't, whatever you use to measure the miles is accurate to plus or minus 0.3, to the tenths. Gallons to the tenths as well. So if you put this down as your answer, you're saying that the apparatus that you use to measure the distance and the volume is beyond laboratory quality. That makes sense, right? Got a lot of significant figures if you just record all of these. So we cannot record all of these because we just learned about these things called significant figures. And I wish that calculators would adjust for sig figs, but they don't. So we have to use our brains. What do you think the correct answer is? 15? Everybody agree? 15? 15.1. So 15.1 or 15. Turns out it's 15. And I'll explain. Rule number 1. There are 2 rules for calculations with significant figures. The first rule covers multiplication and division. With multiplication or division, the answer cannot have more significant figures than either of the original numbers. So the answer cannot have more significant figures than either of the original numbers. So what this means for you is that you need to look at the original numbers, the original calculation. You need to go back to that. So this has how many significant figures? 3 sig figs. 2.8 has how many sig figs?
2.
2. So let's repeat that rule. The answer cannot have more significant figures than either of the original numbers. That means our answer cannot have more than 2 sig figs. So if you look at all these answers that I reported for you, you have 5 here. You have 4 here. You have 3 here. And you have 2 here. So that's how we came up with 15 miles per gallon. Questions on that one? This brings up an important point. Anytime you have calculations and they involve measured numbers, you need to be very, very picky about how you record your measured numbers. Because it's easy to drop a 0 here or add a 0 here, and you can throw off all your significant figures. Yes.
If it was 15.6 something, would you round up or do you just drop that down?
Good question. So rounding does come into play, and I'll cover rounding after the second rule. Good. Okay, the next one, when you add 2.23 plus 4.8197, when you add those two numbers together, and the units should all be grams on these. Shame on me for not recording my units. So your calculator gives you this answer, but you have to take into consideration significant figures. So this is addition. What do you think the correct answer is? 7.05. So 7.050 or 7.05? Yes, this is the correct answer. Very good. This rule, rule number 2, deals with addition or subtraction. And the rule is the answer cannot have more digits after the decimal point than either of the original numbers. So the answer cannot have more digits after the decimal point than either of the original numbers. So now with addition and subtraction, you have to look at after the decimal point. This number, 2.23, how many are after the decimal point? 2 after the decimal point. 4.8197 has 4 after the decimal point. So this is 2, and I put AD. 2 after the decimal point, 4 after the decimal point. So we ended up getting, in our calculator, it reported 7.0497 grams. Well, how did we come up with 7.05 grams? This takes us to rounding, which you were asking about. So you need to have 2 after the decimal point. So I put a bracket around the ones that I'm keeping. So my bracket, anything to the right of my bracket, I'm not keeping. Anything to the left of my bracket, I'm keeping. So I'm dropping a 9, which is a big number to drop. When you drop a digit that's 5 or more, you're going to round the digit you're keeping up 1. So that's how we ended up with 7.05. And on the next page, I have that rounding explained. So if I want to adjust this measurement to 2 significant figures, I would put my bracket between the 4 and the 2. So this is the first removed digit. Sounds like I'm removing a finger or something. Just the number. So if the first digit you remove is 4 or less, drop it in all of the following digits. On the next example, adjust it to 2 sig figs. Where would you put your bracket? Between the 5 and the 8. Excellent. So put your bracket between the 5 and the 8. Everything to the left of that bracket you're keeping. Everything to the right you're dropping. The only digits you look at when you're rounding are the first removed digits. So these digits, I'll highlight them. So I want to adjust this to 2 sig figs. So this one up here would just be 2.4. What would this one be? 4.6. Yes. So if the first digit you remove is 5 or greater, round the number up by adding 1 to the digit you're keeping. And I'll say to the last digit you're keeping. A lot of times students will go through the calculations with the sig figs and they'll count them, and then they get hung up on rounding. So if I have a number 39.60999 grams, let's say. And I want to have 4 sig figs. Adjust to 4 sig figs. No, sorry. 3 sig figs. 3 sig figs. So adjust to 3 sig figs. Where would you put your bracket? After the 6. That's where you put your bracket. A lot of times students feel really uneasy about dropping all those 9s. They just want to add 1 to that 6. But you have to look at the first digit you're losing, or you're removing. So I don't do anything to that one, right? Because it's not 5 or greater. So to round it, it would just be 39.6 grams. All right, so I want you to work on these. Round each of the following numbers to 3 significant figures. So go ahead and do those.